Plant a tree on your birthday. You must have heard numerous such campaigns that ask for planting or saving trees in order to save the earth from pollution. So, what is pollution? Pollution is the harmful effect on the environment that can prove fatal to all living organisms. It is caused by the contamination of the air, water, and soil by harmful substances known as pollutants. Pollutants can be solid, liquid, or gas, and originate from human actions and natural sources. Harmful waste products discarded by humans degenerate in nature. When this rate of degradation is slow, its potential of harm increases. Sometimes, the rate of natural degradation is so slow that the pollutant can cause harm for years and years. Dichlorodiphenyl trichloroethane, commonly called DDT. Heavy metals, many chemicals and plastic are among such pollutants. Now you can understand why we are asked to cut down the usage of plastic bags. Plastic bags take millions of years to degrade and hence do not mix with the soil or water. This results in soil and water pollution. And when burned, such materials emit poisonous gases that cause air pollution. Pollution has been a matter of concern for long, and of late, atmospheric or air pollution has taken the center stage of scientific concern. The much talked about terms, such as global warming, the greenhouse effect, and acid rain are some outcomes of air pollution. Air pollution takes place in two different layers of the Earth's atmosphere, the troposphere and the stratosphere. In this module, we will discuss the pollution in the troposphere. The troposphere is the lowest region of the Earth's atmosphere in which living organisms live. It extends up to 10 kilometers above sea level. Strong air movements and the formation of clouds takes place in the troposphere. Particulate matter and gaseous pollutants cause pollution in this region. The major gaseous pollutants of the atmosphere are harmful gaseous oxides, include the oxides of sulfur, nitrogen, and carbon, besides hydrocarbons. The major particulate pollutants are dust, mist, and smoke. Burning sulfur containing fossil fuels produces the oxides of sulfur. The most common oxide among them is sulfur dioxide. This gas is poisonous for living organisms and causes respiratory diseases like asthma, bronchitis, and emphysema in humans. In plants, a high concentration of sulfur dioxide makes the flower buds stiff and makes them fall off, hampering its reproductive cycle. Coal combustion, ore smelters, petroleum refineries, and diesel engines are some sources of sulfur dioxide. The most common pollutant of nitrogen gas, nitrogen dioxide, is produced when fossil fuels are burnt in high temperature, like in automobile engines. Dinitrogen and dioxygen are the main constituents of air, and they form nitric oxide and nitrogen dioxide in high temperature. Nitric oxide also reacts with the ozone in the Earth's atmosphere to form nitrogen dioxide. Nitrogen dioxide can cause respiratory diseases in children, irritate the eyes, lungs, and throat, and damage the leaves of plants, affecting their photosynthesis. An increase in the level of the oxides of sulfur and nitrogen makes the pH value of rainwater drop below 5.6, causing acid rain. Acid rain washes away nutrients from plants and is harmful for trees and agriculture. It causes respiratory diseases in humans and animals. Acid rain flows to rivers, lakes, and oceans and harms the ecosystem in them. The acid particles corrode metals and stones, damaging structures made of them. The Taj Mahal, the beautiful monument in India, is being disfigured and rendered lusterless by acid rain. Another air pollutant, hydrocarbons, is produced as a result of incomplete combustion of fuels in automobile engines. In animals, hydrocarbons can cause cancer, while in plants, they cause aging by breaking down tissues, which causes shedding of leaves, twigs, and flowers. Other major gas pollutants are the oxides of carbon, namely carbon monoxide and carbon dioxide. Carbon monoxide is produced by automobile exhaust and incomplete combustion of fossil fuels. This highly poisonous gas combines with hemoglobin in blood, forming carboxyhemoglobin. When the concentration of carboxyhemoglobin reaches 3 to 4%, it reduces the oxygen carrying capacity of blood. This results in headache, weak eyesight, and cardiovascular disorders. In extreme cases, it can also cause death. Carbon dioxide is perhaps the most commonly known air pollutant that is produced in respiration, burning of fossil fuels, and decomposition of limestone. Generally, the balance of carbon dioxide in the atmosphere is maintained by the green plants. As you know, during photosynthesis, plants take carbon dioxide and release oxygen. Therefore, cutting down trees and burning fossil fuels damages atmospheric balance. An increase in carbon dioxide leads to an increase in the average global temperature. This is known as global warming. Let's understand how. Our Earth is covered with a multi-layered ball of air called the atmosphere. When the sun's rays come towards the Earth, one layer absorbs the harmful rays like ultraviolet rays and lets the rest pass to reach the Earth's surface. Near the Earth's surface, another layer traps the sun's heat so that the Earth is perfect for life. In response, the Earth's hot surface also sends back some infrared light, a part of which is sent back to space through the atmosphere. This process is very much similar to a greenhouse, where the glass holds the sun's heat inside. Therefore, gases in the atmosphere that traps the sun's heat are known as greenhouse gases. Water vapor, carbon dioxide, nitrous oxide, and methane are some of the major greenhouse gases. When the level of greenhouse gases in the atmosphere increases, they trap more heat from the sun and also from the Earth's surface. As a result, the atmosphere becomes warmer, and in a few years may lead to the melting of polar ice caps and the flooding of low-lying areas all over the Earth. This is what we call global warming. Global warming brings in various deadly diseases like dengue, malaria, and yellow fever to mankind, as it provides bacteria and viruses an environment favorable for their growth. By now, you have seen how much damage is being done to our Earth's atmosphere every day. So do your bit to save our planet by planting trees, reducing the use of fossil fuels, and saying no to plastic. This will help save our one and only home from further damage. Smoke is either solid or a mixture of solid and liquid airborne particles. It is produced by the combustion of organic matters and is harmful for plants and animals. When solid material is subjected to chiseling, grinding, or crushing, it produces fine particles that are about 1 micrometer in diameter. These are called dust. Dust is also emitted in sandblasting, pulverization of coal, fly ash from factories, and dust storms. Mists are liquid particles produced by spray liquids or vapor condensation. Sulfuric acid condensation and spraying of insecticides or herbicides produces mist. Another particulate pollutant, fumes, is basically a result of condensation of vapors produced in the processes like sublimation, distillation, boiling, etc. Metallic fumes are also produced from the reaction between organic solvents, metals, and metal oxides. Smoke is either solid or a mixture of solid and liquid airborne particles. It is produced by the combustion of organic matters and is harmful for plants and animals. When solid material is subjected to chiseling, grinding, or crushing, it produces fine particles that are about 1 micrometer in diameter. These are called dust. Dust is also emitted in sandblasting, pulverization of coal, fly ash from factories, and dust storms. Mists are liquid particles produced by spray liquids or vapor condensation. Sulfuric acid condensation and spraying of insecticides or herbicides produces mist. Another particulate pollutant, fumes, is basically a result of condensation of vapors produced in the processes like sublimation, distillation, boiling, etc. Metallic fumes are also produced from the reaction between organic solvents, metals, and metal oxides. Among the particulate pollutants, those that are 1 micron or smaller in size can enter the lungs easily and harm human beings and animals alike. On the other hand, pollutants bigger than 5 microns may get lodged in the nasal passage. Therefore, the smaller a pollutant, the greater is its potential to harm. Apart from particulate pollutants, 2 other major air pollutants are lead and smog. Lead affects the maturation and development of red blood cells in animals. It is mostly emitted by vehicles that use leaded petrol. Smog is a mixture of smoke and fog and is the most common cause of air pollution in major cities. Smog is of 2 types, classical smog and photochemical smog. Classical smog is composed of smoke, fog and sulfur dioxide. This type of smog generally occurs in a cool, humid climate. Photochemical smog occurs in warm, dry and sunny climate. Photochemical smog is also known as oxidizing smog for its high concentration of oxidizing agents. When the sun rays hit the particles of unsaturated hydrocarbons and nitrogen dioxides, photochemical smog is formed. Photochemical smog consists of ozone, nitrogen dioxide, acrolein, formaldehyde and peroxyacetyl nitrate. These chemicals are produced in a chain reaction of unsaturated hydrocarbons and nitric oxide emitted by burning of fossil fuels, factories and automobiles in the presence of sun rays. First, the nitric oxide combines with oxygen to form nitrogen dioxide. This nitrogen dioxide absorbs energy from sunlight and breaks up to form nitric oxide and nascent oxygen. The oxygen atom, thus produced, reacts with oxygen gas in the air and forms ozone. This ozone reacts with nitric oxide and forms brown nitrogen dioxide gas. Both nitrogen dioxide and ozone can react with unburnt hydrocarbons to form chemicals such as formaldehyde, acrolein and peroxyacetyl nitrate. These components of photochemical smog cause health hazards in animals and in man, such as eye, throat and lung irritation, headache, chest pain, cough, difficult breathing, etc. It also corrodes metals, stones, building material, rubber and painted surfaces. Therefore, it is very important to control the formation of photochemical smog. Taking control over the production of nitrogen dioxide, hydrocarbons, ozone and peroxyacetyl nitrate will help to prevent photochemical smog. Using catalytic converters in automobiles reduces the emission of nitrogen dioxide and hydrocarbon. Also, certain plants such as Pinus, Juniperus, Quercus and Pyrus can metabolize nitrogen dioxide and thereby help to reduce photochemical smog. We can also cut down a lot of pollutants by recycling waste material. On a sunny summer day, we usually carry an umbrella or use a sunscreen. Do you know why? It's because To an extent, we all can see the harmful effects of the sun's rays. The tanning and burning of the skin are the effects observed normally. However, these are the least harmful, because sun rays can also cause skin cancer and cataract. With the increasing atmospheric pollution, we are being exposed to more and more such risks. Let's understand how. Sun rays contain ultraviolet or UV radiations. The second layer of atmosphere, or the next layer of troposphere, is called the stratosphere. In the upper zone of stratosphere, the protective layer of atmosphere called ozone layer is present. Ozone is produced when the ultraviolet radiations collide with the dioxygen molecules present in this layer. First, the UV rays dissociate a dioxygen molecule into its respective oxygen atoms. This oxygen atom, called nascent oxygen, then combines with another oxygen molecule to form an ozone molecule. As an ozone molecule is thermodynamically less stable, it undergoes dissociation to produce oxygen molecule and oxygen atom respectively. Hence, the above reaction results in dynamic equilibrium between ozone and its corresponding oxygen molecule and nascent oxygen. The ozone forms a thin layer surrounding the Earth's planet. It protects animals and plants from the harmful UV radiations by acting as an umbrella that absorbs most of the UV rays. Although the formation and dissociation of ozone is a continuous process, it has been observed that the ozone layer is depleting rapidly due to the increasing pollutants like chlorofluorocarbons or freons in the stratosphere. These compounds are non-reactive, non-inflammable and non-toxic organic compounds that are constantly being generated from refrigerators, air conditioners and electronic industries, to name a few. When these compounds reach the stratosphere, they are hit by the UV radiations and dissociate into corresponding fragments, releasing free chlorine radicals. These free chlorine radicals react with the ozone and form chlorine monoxide radicals and oxygen molecules. The chlorine monoxide radicals form even more chlorine radicals by reacting with nascent oxygen. Thus, the chlorine radicals are constantly regenerated and they keep reacting with the ozone to form chlorine monoxide. Thus, ozone gets depleted in the stratosphere. In Antarctica, ozone depletion reactions occurs in spring as it requires the presence of sunlight. During the dark days of the winter, the region gets covered with polar stratospheric clouds. During summer, nitrogen dioxide and methane react with chlorine monoxide and chlorine free radicals and form stable reservoir compounds like chlorine nitrate, ClONO2, and hydrogen chloride, HCl, respectively. In winter, the polar stratospheric clouds provide a surface by which chlorine nitrate hydrolyzes to hypochlorous acid and nitric acid. Also, chlorine nitrate reacts with hydrogen chloride to form chlorine molecules. And the chlorine-containing gases, along with nitric acid, form cloud particulates. Due to the lack of sunlight, these clouds remain chemically stable for almost 3 months without causing any harm to the ozone layer. However, during spring, in the presence of sunlight, the hypochlorous acid as well as chlorine molecules undergo further photolysis to form chlorine-free radicals. Thus, in spring, chlorine radicals which are constantly added initiate the chain reaction. This free chlorine radical is initially removed by reaction with ozone to form chlorine monoxide. However, it reacts with another oxygen atom, regenerating the free chlorine radical. As the rate of the chain reaction taking place is very high, ozone has depleted completely from a large area over the southern hemisphere, forming a hole in the ozone layer. This is called the ozone hole. The increasing use of fossil fuels and electronic goods has led to increasing pollution. This has thinned down the ozone layer over many places at an alarming rate. As a result, more UV radiations are entering the troposphere, causing aging, sunburn, skin cancer, and cataract, besides damage to reproductive functions in some fish. In plants, UV radiations cause mutation of cells by affecting plant proteins, increase the evaporation of surface water through the stomata of the leaves, and kill phytoplanktons. UV radiation also decreases the moisture content of soil and fades paints and fiber, causing huge economic losses. Therefore, we all need to ensure a reduction in stratosphere pollution by reducing the use of chlorofluorocarbons, nitrogen dioxides, and methane-releasing compounds. Water is life. All living organisms need water to survive. About 60 to 70% of the human body is made up of water. It is also vital for animals and plants. According to the World Health Organization, every year, about 3.4 million people in the world die due to diseases caused by contaminated water. Of these, 86% get infected due to contaminated groundwater and 14% due to contaminated surface water. The diseases are caused by parasites, bacterial infection, and other microscopic pathogens that contaminate the water. It is, therefore, very important to check the purity of the water we use. Groundwater is a natural source of pure water. However, pollutants reach groundwater through different paths, like seepage and agricultural runoff, and contaminate it. Pollutants get added to water at two places: point sources and non-point sources. Point sources are the easily identifiable sources of pollution, such as municipal and industrial discharge pipes. Through these sources, pollutants enter the water source. Non-point sources are not easily identifiable, such as agricultural runoff from farms, acid rain and stormwater drainage from streets and parking lots, etc. These sources add pollutants like pathogens, organic wastes, and chemicals to water. Pathogens are the most harmful water pollutants. They include disease-causing microorganisms like bacteria and viruses. They enter water from domestic sewage and animal excreta. Escherichia coli and Streptococcus faecalis are some pathogenic bacteria that cause gastrointestinal diseases. Other causes of water pollution are excessive growth of phytoplankton and dumping of biodegradable organic waste such as leaves and grass. When these organic matters fall into water, bacteria decompose them. These bacteria consume the oxygen dissolved in the water. As the concentration of oxygen in water is very less as compared to that in air, even a little amount of oxygen consumption can cause oxygen depletion and adversely affect the dependent aquatic life. Therefore, when a large amount of organic matter gets added to water, it depletes the oxygen in it rapidly, causing death to the dependent aquatic life. The dead aquatic animals form organic waste. They are broken down by anaerobic bacteria, which break down these waste-producing harmful chemicals with a foul smell, and by aerobic bacteria, which lead to further depletion of oxygen from the water. The total amount of oxygen required by bacteria to break down the organic matter present in a certain volume of water is called biochemical oxygen demand, or BOD. BOD is directly proportional to the amount of organic material in the water. The BOD value of clean water is less than 5 parts per million. Another major cause of water pollution is chemical pollutants like heavy metals, fertilizers, pesticides, and some harmful elements. Heavy metals such as cadmium, mercury, and nickel are water soluble, and the human body cannot excrete them once they get in. These metals damage the kidneys, the central nervous system, and the liver. Acids from mine drainage such as sulfuric acid and salts like sodium and calcium chloride are also water-soluble chemical pollutants. Apart from these inorganic chemicals, organic chemicals like petroleum products, pesticides, and industrial chemicals also add to water pollution. Petroleum products like oil do not dissolve in water and pollute water sources. Oil spills that affect marine life in the oceans are a catastrophic example of water pollution. Pesticides get mixed in water from sprays or from soil and pollute water. Industrial chemicals include polychlorinated biphenyls or PCBs, which are thought to cause cancer. PCBs are used as cleansing solvents, detergents, and fertilizers. Bacteria that decompose biodegradable detergents grow rapidly on it. These bacteria reduce the oxygen in water and cause a threat to other aquatic life. On the other hand, fertilizers contain phosphates that increase algae growth in water. Algae cover the surface of water, blocking sunlight and depleting oxygen in the water. The reduction of oxygen concentration in water causes the death of many aquatic organisms. This process of rapid plant growth in water and the depletion of oxygen causing the death of animals results in a dysfunctioning ecosystem called eutrophication. Thus, we can see that water is very vulnerable to contamination and that we should ensure the purity of drinking water. The international standard followed for drinking water prescribes the usable amount of some elements in it, such as fluoride, lead, sulfate, and nitrate. For ideal drinking water, the fluoride ion concentration should be 1 part per million. Fluoride concentration less than that causes tooth decay, while a higher concentration can cause brown mottling of teeth. A concentration of 10 parts per million of fluoride can harm the bones and teeth. Drinking water usually gets contaminated by lead that comes from water pipes. Excessive concentration of lead can cause damage to the kidney, liver, and reproductive system. The concentration of lead in drinking water should not exceed 50 parts per billion. Sulfate in a moderate amount is not harmful, but if it exceeds 500 parts per million, then it may cause a laxative effect. Another element, nitrate, can cause diseases like methemoglobinemia if it exceeds a concentration of 50 parts per million. We should also check for the concentration of some metals like iron, manganese, copper, zinc, aluminium, and cadmium in drinking water. We can cut down about half the amount of water pollution on the earth by taking care of the sewages coming from our houses. Do you know that our body is at risk even when we think that we are consuming fresh fruits and vegetables? It is because most of the fruits and vegetables we use today contain chemicals. Chemicals are used during cultivation as pesticides and herbicides for better yield. These chemicals don't just kill pests and weeds, but also pollute the soil where they are used, thereby affecting the surrounding ecosystem. Pesticides are substances intended for preventing, destroying, or controlling any pest. Pest includes insects, mice, and other animals, unwanted plants, fungi, or disease-spreading microorganisms like bacteria and viruses. Insecticides and herbicides are also kinds of pesticides. Generally, pesticides are synthetic toxic chemicals that are harmful to the environment. However, if the same or similar kind of pesticide is used continuously a number of times, the pests grow resistant to them. That is why pesticides with highly concentrated organic toxins were made. For example, when insects grew resistant to DDT, organic toxins such as aldrin and dieldrin were introduced. These pesticides are water insoluble and non-biodegradable, and therefore harmful for the atmosphere. Moreover, the toxins are carried from the lower species to the higher species through the food chain. The toxins become more concentrated with each consuming rung. Although the chemical effects is minimal in the lower level species, it becomes dangerously concentrated when it reaches the upper level species, such as humans. In humans, it causes serious metabolic and physiological disorders. Because of the harmful effects of organic toxins, more biodegradable products with less toxin concentration, known as organophosphates and carbamates, were introduced. However, these chemicals turned out to be more harmful to humans as they contain severe nerve toxins that can cause death. Another type of pesticides that has become popular of late are herbicides like sodium chlorate and sodium arsenite. Herbicides decompose in a few months and hence are less persistent than organic toxins. However, herbicides are toxic to mammals. They sometimes cause birth defects in some mammals. The toxicity of herbicides also increases with the higher level species in the food chain. These chemicals, including pesticides and herbicides, are harmful not only for living organisms but also for the soil. Chemicals contaminate the soil, resulting in plant metabolism alteration with a reduction in the crop yield. Humans and other animals who live near contaminated soil are exposed to all the health risks that these chemicals bring in. DDT was found to be a great disease control tool during World War II. After the war, it was used on a very large scale to control insects, rodents, weeds, and various crop diseases. However, the ill effects of DDT on human health came to light later on. Today, some countries have banned its use. Soil pollution can also lead to water contamination and hence should be treated effectively. We know that industrial waste pollutes the air, water, and soil. Solid industrial waste can be categorized as biodegradable and non-biodegradable. Biodegradable waste consists of plant and animal waste that can be degraded by microorganisms. Non-biodegradable waste consists of material that cannot be degraded and remains as such in the environment. It is more harmful than biodegradable waste. Biodegradable waste is produced in industries like cotton mills, food processing units, paper mills, and textile factories. Non-biodegradable waste is produced by thermal power plants, integrated iron and steel plants, and fertilizer industries, among others. It includes fly ash, blast furnace slag, steel melting slag, and chemical sludge. Industries dealing with metals, chemicals, dyes, drugs, pesticides, rubber goods, etc. also produce harmful wastes such as inflammable substances, explosives, or highly reactive substances. If burnt, These wastes emit smoke containing particulates of harmful chemicals. Therefore, it is very important to dispose the waste using the proper methods. A simple three-way method is denoted by 3 R's, which stand for reduce, reuse, and recycle. The first R, reduce, implies a reduction in the amount of waste that is produced by the usage of materials. For example, instead of carrying plastic bags, we should carry our own cloth or jute bags when we go out for shopping. Instead of throwing away plastic bags after one use, we can use it again. This is reuse. This brings us to the third R of waste management, which is recycle. Recycling helps to produce the same or a different kind of material from a used one. For example, certain plastics can be recycled to produce many common household items, like shoes, rugs, bags, etc., and even clothes. Another example is the use of fly ash and slag from the power industry and steel industry by the cement industry. Such measures reduce pollution by controlling waste and is known as waste management. Waste is produced at many spots, from where it has to be collected for proper usage or disposal. In a proper waste management system, domestic waste is collected in small bins and then transferred to community bins. From the community bins, waste is collected and carried to the disposal site, where the garbage is sorted out and separated into biodegradable and non-biodegradable material. The non-biodegradable material like plastic, glass, and metal scrap is sent for recycling, while the biodegradable waste is deposited in landfills to convert it into compost. If the waste is not properly collected in garbage bins, it can get into the sewers and cause choking. It can mix with groundwater, contaminating it and leading to health problems in humans and animals. Worse, it can cause death if consumed by animals. While collecting waste, special care should be taken by the workers to protect themselves from its harmful effects. When human beings are in direct contact with toxic wastes, they become more prone to diseases caused by harmful chemicals. This can be prevented by using protective devices such as gloves or waterproof boots and gas masks. Though recycling is one of the easiest ways to reduce waste, only about 31% of waste is currently being recycled on the earth. Therefore, the next time you go shopping, do not forget to opt for something recyclable. We know that the Earth's atmosphere, along with its soil and water, is polluted every day, and it is not possible to eliminate the causes of pollution, such as industries and vehicles, all at once. However, it is possible to find alternate production methods that would not pollute the environment as much as the current methods. The branch of chemistry which deals with the research and discovery of such methods is known as green chemistry. Green chemistry uses existing scientific knowledge to help find environment-friendly and cost-effective production methods. It suggests that industries use chemical reactants that yield optimum products and minimum waste. as combating the environmental impact of these chemicals is a costly venture in terms of time, energy, and money. Green chemistry emphasizes on the prevention of harmful chemical impact through a chemical process that involves decreasing the amounts of harmful chemicals to achieve zero discharge of pollutants and emissions. Let's understand how. All chemical reactions involve reactants, attacking reagents, and the medium in which the reaction takes place. If the reactants in a chemical reaction are completely converted into environment-friendly products through an environment-friendly medium, then there would be zero discharge of pollutants. Synthetic reactions can be carried out in an aqueous medium as water is cost-effective, non-inflammable, and free from carcinogenic effects. The use of green chemistry in our day-to-day life can be seen in dry cleaning of clothes, bleaching of paper, and chemical synthesis. For dry cleaning of clothes, earlier tetrachloroethene was used, a suspected carcinogen which also contaminates groundwater. This process has now been replaced by a process of using liquefied carbon dioxide with a detergent that results in less harm to groundwater. Nowadays, hydrogen peroxide is used for bleaching in the process of laundry, as it gives a better result with the use of less water. Hydrogen peroxide is also used for bleaching paper, which was earlier done by using chlorine gas. In chemical synthesis, ethanol is now prepared by one-step oxidation of ethene in an aqueous medium in the presence of an ionic catalyst. This gives a yield of 90%. In 2005, Yves Chauvin, Robert H. Grubbs, and Richard R. won the Nobel Prize in Chemistry for work that reduces hazardous waste in creating new chemicals, which, in other words, involves the goal of green chemistry.